In this video, we'll learn how to simplify radical expressions. First of all, let's understand what it means to simplify a radical expression. A radical expression for a square root in particular is simplified when its radicand has no factor other than one that is a perfect square. So when we think about a radical expression, we can think about it as a number, but if it has any factors within it that is a perfect square, we need to simplify it. In order to do that, we're going to have to factor that square root apart into two different square roots. Now, this might seem a little confusing, but let's look at an example here to see what this looks like. Let's consider the square root of 36. We know that the square root of 36 is actually just the number 6. But if we think about several steps that we could do to factor this apart, there's more than one way to simplify this. So consider this. The square root of 36 is really the same thing as the square root of 9 times 4, which could actually be written as the square root of 9 times the square root of 4. The square root of 9 is 3, and the square root of 4 is 2, so 3 times 2 is 6. Now, because we know the square root of 36, we're able to go straight to this final step. But if we don't know what the square root of a number is, and it has a perfect square factor, we might need to do these steps. So let's look at the square root of 20. For the square root of 20, we don't know what the square root of 20 is, but it can be simplified further. That's because the square root of 20 is the same thing as the square root of 4 times the square root of 5. And that's important to know because the square root of 4 is a perfect square factor. So we need to simplify this. So let's go to the next step. That can be factored into the square root of 4 times the square root of 5. And that's important because we know what the square root of 4 is. The square root of 4 is just 2. And the square root of 5 stays the same since we don't know what that is. So when we simplify the square root of 20, it's actually 2 square root of 5. 2 times the square root of 5. So that's where it's important to know how to factor a radical expression apart to write it in a more simplified form. So let's look at a couple more examples. In order to simplify a radical expression, the first thing you want to do is consider, you want to try and identify if there's any perfect square factors in each number. So think about the square root of 50. This could be factored into the square root of 5 times the square root of 10. But that's not going to be helpful since the square root of 5 and the square root of 10, neither of those are perfect squares. So let's go back and think about what our factors of 50 are. And if we think about it, we can think about this. Square root of 50 is actually the square root of 25 times the square root of 2, because 50 is 25 times 2. And that's important to know because 25 is a perfect square. So our next step would be to say that the square root of 25 is 5, and we keep the square root of 2 since that can't be simplified anymore. So now this is a simplified radical expression. Let's go to the square root of 18. Again, we want to think about what our factors of 18 are, and we want to think only about the perfect squares. Is the perfect squares like 4 or 9 or 25 or 16? And if you think about your perfect squares, we know that 9 is a factor of 18. So we want to factor this into the square root of 9 times the square root of 2, which is actually 3 times the square root of 2. And let's look at this last one, the square root of 10. Well, the square root of 10, the only factors of that are the square root of 5 and the square root of 2, or the square root of 10 and the square root of 1. But we don't want to, let's think about the square root of 5 and the square root of 2. Neither of those two factors are perfect squares. And as a matter of fact, there are no perfect square factors other than 1 for the number 10. So that means that this is actually already a simplified radical expression. So you can only simplify it if it has a perfect square factor within the radicand. Now this also applies for variables as well. So let's think about the variable, each one of these radical expressions. The square root of a to the 6th b. Let's begin by thinking about, well, let's factor that into the two different variables. And let's treat them each separately. So let's think about the square root of a to the 6th. If you think about this, a to the what power times a to the what power would give us a to the sixth. And if we remember, we know that that's going to be a to the third times a to the third is a to the sixth. So let's make that a little bit clearer. A to the third times a to the third is a to the sixth. So if we think about what the square root of a to the sixth is, that must be a to the third. And for the square root of b, that can't be simplified because that's not a perfect square. So this is our simplified expression for a to the third for the square root of a to the sixth b. Now let's do one more. This time has a radicand, which is both has a coefficient and two different variables. So let's begin by breaking this into, let's factor this into three different parts. One's for the coefficients, and then one's for each variable. Now let's treat each of these a little bit separately. The square root of 18, we just did this on our last slide. We know that that's the square root of 9 times the square root of 2. We factor that into its perfect square. Well, for t to the 7th, if we think about t to the 7th, it's hard to think about what that number would need to be to give us 7. As a matter of fact, it would have to be a 3.5 and a 3.5. And we don't want to go to decimals when we're trying to think about this, when we're trying to simplify this. So instead of thinking about it as t to the 7th, what we should think about is factoring this into t to the 6th times the square root of t, because that's what would give us t to the 7th. So with an odd number as an exponent, let's break it down into the next lowest even exponent. And then let's keep this as a square root of u to the 2nd. Now let's simplify each one of these radical expressions that has a perfect square. The square root of 9 is 3. The square root of 2 stays like that. The square root of t to the 6th is t to the 3rd. It's actually similar to this problem we did over here, just a different letter. The square root of t remains the square root of t, and the square root of u squared is u, because u times u is u squared. Now let's write this all together so it's a little bit more clear. Let's put all of our numbers that are not radicals any longer and variables. So we'll put 3t to the 3rd u out in front of our radical expression. And inside of the radical expression, we'll keep the 2t. And that's how you simplify a radical expression.